This is 9(1)b, multiplying and dividing rational expressions. All right, so this concept of a complex fraction, we want to be able to work with it, simplify it, so that we can expand our understanding of rational expressions, okay? So a complex fraction is a fraction divided by a fraction. To simplify, flip the denominator and move it up top, then multiply, okay? So if you have 1/2 divided by 3/4, you just keep the 1/2 like it is, and then you take the bottom part, you flip it, and multiply. Flip and multiply. Okay, remember division by 0 is undefined. We can throw variables in there too, like this, okay? The couple of notes that I do want to give you before we dive in: factor as much as possible, okay? And then you can cancel out like factors or quantities that appear both in the numerator and the denominator, okay? That are multiplied in both numerator, I'm going to abbreviate that, both numerator and denominator, okay? So we have a fraction to a fraction, x plus 1 over x plus 4, divided by x squared minus 1 over x. So first thing we're going to do is flip and multiply, okay? Flip and multiply. So we'll take the numerator, leave it, and then we're going to take the denominator and we're going to flip it so the x moves up top. X squared minus 1 goes here, and then we'll multiply straight across as we do with fractions, okay? So x plus 1 is being multiplied by that x. I'm just going to write the x out front because it's more common mathematical notation to do that. You have to put this x plus 1 quantity in parentheses, okay? And then we have x plus 4 quantity, and x squared minus 1 is also a quantity, okay? Because we multiplied straight across. Now, factor, okay? So the x and the x plus 1, those can't be factored at all. But look down here. Look at this x squared minus 1. That can be factored into x plus 1 times x minus 1. And then we still have our x plus 4. And we're at a point now where we have two quantities that appear, or excuse me, we have two quantities that can cancel out, okay? X plus 1 up here, x plus 1 down here. So that cancels. And everything else just stays the same, okay? X is now alone in the numerator, and then we have x plus 4 and x minus 1. Nothing else can be simplified because our x doesn't appear in the denominator, and our x plus 4 quantity doesn't appear in the numerator. X minus 1 does not appear in the numerator either, so we are done, okay? These are really, really fun, but they do take some practice, especially if you struggle with factoring. All right, let's try this one. These complex fractions or division of these expressions can appear like this as well. So instead of seeing it as a complex fraction, you could see it with a division symbol, in which case you should just flip it first. Flip the second thing. Okay, flip this. So it becomes 5x plus 2 over 2x plus 5. Multiply. Okay, flip and multiply. And then our left expression didn't change. Okay, flip and multiply. Then factor. Factor as much as possible as you multiply straight across, okay? This 4x plus 12 can have a 4 factored out of it. And I'm just going to now multiply straight across, and that 5x plus 2, it's almost like there's just a big fraction bar here, okay? Our denominator, remember these are quantities. Can we factor at all? Anytime you see something squared, you should try to factor it, okay? 25x squared and 4, we should be able to recognize that 25, 4 are both perfect squares. And so we can actually factor this, okay, into 5x plus 2, 5x minus 2. And then our 2x plus 5 will stay the same. Now cancel stuff out. Cancel out quantities. Okay, 5x plus 2 appears in both the numerator and the denominator. No other quantities do. Okay, so here's our final answer. 4 times x plus 3 divided by 5x minus 2 times 2x plus 5. We are done. Okay, flip and multiply, factor, cancel out. Same 3 steps. All right, this is division. So flip and multiply. Okay. Oops, forgot to flip. Silly me. Okay. And then our left side stays the same. Our left expression, I should say. And then this is where factoring gets tricky, maybe, if you're a little rusty on it. Multiply, then factor. Okay, so let's factor anything that we can. When I say factor, I mean GCFs. I mean factor into two binomials using the AC method. I mean factor by grouping. Okay, all our factoring tools, we gotta use them here. Okay, 3x and negative 24y, we can factor out a 3. Okay, and we're left with x minus 8y. Our denominator, x squared minus 36y. This is 36y squared. Okay, that can be factored into x plus 6y, x minus 6y. Okay, x minus 8y, that cannot be factored. And then, but our numerator over here can. Okay, x squared plus 3xy minus 18y squared. Think about your factors of a times c, your factors of 18, right? 1, 18, 2, 9, 3, 6. We can play around with the 3 and the 6 in order to get what we want. Okay, so x plus 6y and x minus 3y should factor. Yeah, that should be what we want. Okay. And then now we can view this kind of like as one fraction bar. Cancel out. Okay, so now we're going to cancel out. X minus 8y, that appears in both the numerator and the denominator. X plus 6y. Okay, nothing else appears. You have to be in fully factored form. Okay, this method only works if you're in fully factored form. Say that we hadn't factored out this 3. Then we would see 3x minus 24y, and we wouldn't notice this x minus 8y cancels out. Okay, so if you're not in fully factored form, you're not going to get down to fully simplified form. All right, and then everything else that didn't get crossed out, we just write as is. Okay, 3 times the quantity x minus 3y divided by x minus 6y. I don't really need to put parentheses around x minus 6y because there's nothing else in the denominator being multiplied by it. Okay, and there you go. That's the tough part, okay, is dividing. The next two we're going to see are just multiplying, so we don't flip. Okay, notice this is multiplication. Don't flip here. We only flip when there's division. Don't flip, okay? It's up to you how you want to go about this. Some people want to multiply straight across and then simplify from there. If that works for your brain, go ahead. You could work with 72 y to the third x to the fifth divided by 6xy and then simplify from there. Or you could kind of simplify along the way. All right, think about this as one big fraction bar. 8x divided by 2x. So because we have all multiplication and in the numerator and the denominator, we can just like cancel out as we see it. Okay, 8x over 2x, that could cancel and just give us 4. The 3 and the 9 and the 3 could cancel and leave us with a 3 in the numerator. And then our y's, we have y to the third on top and y on the bottom, so this could leave us y squared. and then our x to the fourth just stays. So overall we end up with 4 times 3 times y squared times x to the fourth, which is 12 y squared x to the fourth. Okay. Or if that's too tough for you to see, you could work it like this. Okay, 8x over 3y. I'm just going to work from the original. Okay, 9y to the third x to the fourth over 2x. Say you multiply straight across, that's fine. 72 y to the third x to the fifth. Just be careful with your exponent rules if you do it this way. And then 6yx. Now look at 72 divided by 6. You'll get 12. Look at y to the third divided by y. You'll get y squared. Look at x to the fifth divided by x. You'll get x to the fourth. Okay? Two different ways of doing the same thing. Last one. Again, we have multiplication, so don't flip. Okay, we only flip for division. So my suggestion, because we have some quadratics here, factor first, okay? Let's factor this numerator and this denominator. Let's use the AC method to do that. All right, 3 times 21 gives us 63. So some factors of 63, 1, 63, 3, 21, 7, and 9. Okay, and then we want to work with 7 and 9 because we want that negative 2 in the middle, so we'd have like 3x squared. I'm kind of like doing this work off to the side, and then I'll put my factored form in the fraction when we're ready for it. Okay, so here we're factoring using the AC method, right? The GCF of 3x squared minus 9x is 3x, so we can factor that out like this, and then we can factor out a 7. And now because there are two x minus 3 quantities, we can factor them like this. Okay, and that means our numerator here on the left is x minus 3, 3x plus 7. All right, you can do the AC method again to factor this denominator. When you do that, I'm just going to simplify a little bit. You get 2x minus 7 times x minus 1. Again, I got that by the AC method. I just didn't write it out. And then let's see if we can factor anything here. 2 and 7 don't have a GCF, so I'm just going to leave that numerator. 4x and 12, they have a GCF of 4, so we can write this as 4 times the quantity x minus 3. Okay, so that was us factoring. Factor completely. Okay, and then cancel out. Cancel out stuff, okay? So I have 2x minus 7 in the bottom and the top, x minus 3 in the top and the bottom, nothing else. So my numerator will stay 3x plus 7, and my denominator will become 4 times the quantity x minus 1. If you wanted, you could distribute that 4 and write it as 4x minus 4. It doesn't matter to me. Either one is fine. Okay? That's all I got. Take a look at your practice and let me know what questions you have.